But for nursing, this will probably be your biggest challenge, is that this is the circuit for it. So this, well, you can put an OmniFlex here, but that attaches to a patient. So if everyone wants to do a little hold, that's now touching your patient.
Is this the same one that you showed us on the other bit a while ago?
Yeah.
So the ET tube goes like
yeah,
a little
so that little lung is our patient. So we could put one flexion tubing in there, but we can't put a ton. The reason I'm having you guys touch it and hold it is because there's weight to that, and it has the ability to pull on the ET tube.
This weighs more than a 24 liter.
It will sit in
Yeah, it will sit nicely. It's important to remember, but I can tell you that they've transported on extremely small patients with this. Once you are very aware of it, you get kind of good at building shelves. You guys all know how to build shelves and use blankets to make sure that you keep things secure. It can go either direction. So like it can be laying flat, it can be up top. The only thing we want to make sure is we don't block off that piece right there, because that's technically this piece too, but it'd be really hard. But this is an entrainment port, so it pulls in volume to be able to meet the demands of the patient.
Is that for both the regular vent and the high five?
No, it's just the high frequency. I'm only the high frequency guy.
Oh.
The Hamilton guy is a completely separate, and that's because, and there's a whole Zoll person here. These things have a lot of capability, so we want to make sure we give you the best resources we can. So it's a little tucked away here. So this is where the TXP is. You're also, for you guys, this is where your blender and your flow meter is. So you have your flow meter output, and then the flow meter just it just pops. It's this little dial that you turn to the flow you want. And then the blender's actually right here for FIQ control. So for the circuit, we connect red to red and white to the other one. And then there's a little switch that says TXP on or off. So once I turn this on, it's prioritizing gas to the high frequency vent. So it will come in the package, like not on the ground. And then you'll connect your red and white, so it's white right here. And there's no red connection right here, so it's just putting it on the other one. I think on newer ones there's a little red connection here now, but mine's a little older of a disposal. So we'll connect to our patient here. I'm going to, after I kind of like demo it, I'll show you a guideline that you guys can use. It's probably as far as we can really go for the most part in guidance. So the first thing we do is we turn on amplitude. This is ultimately just turning on flow to get this thing to wake up. So we usually get our amplitude up and we look for chest wiggle. A little subjective, but chest wiggle is an ultimate indicator if we're going to be ventilating the patient. And when we get it up to a chest wiggle we feel is adequate, we will look at this big number, which is a mean airway pressure. A little hard to see here, but it's the big number in the middle. Mean airway pressure is the only thing that is shared between all ventilators. So when we think of a conventional ventilator, oscillator, jet, they all share that number. So it gives us somewhere of a starting point to go. So if we have a patient that is on, let's just say, a MAP of 8. Well, if I go and I'm now on 4 on just amplitude, do you think we can ventilate that patient? It's probably not likely because they're probably seeing a little bit higher mean. So this knob, which is basically a little peep knob, allows us to kind of fine tune our MAP down to where our target is. So if I'm targeting 8, I'll crank down on this, and you'll notice a difference. It's like nothing's happening, and then all of a sudden a lot of things it'll be very sensitive. Going up. Overshot a little bit. So plus or minus 1, so I'm on 9 right now. There's a 3-digit number, which is the high frequency pulsing. So how many pulses a minute we do. General guideline, we talk about being at 500 to start, and then we can go up and down based off gas exchange, gases. So I'll just touch it up to close to 500. This ventilator is not one, if you really like numbers to be exact, it has some float a little bit, especially because you're using gas. It's 100% gas source. So, exact numbers sometimes you'll see when we go from the wall to the tanks, you'll have to recheck. When you go from back to the tanks, you'll have to recheck. So roughly around 500, MAP of 8. So our basics for gas manipulation, if we want to blow off CO2, is that we would manipulate our amplitude in 1 to 2 centimeter increments. So if we're at 8, we would go up to 9 to 10 to blow off CO2. That will inadvertently also help oxidation because you're increasing mean airway pressure. Now, if I talked to Dr. G, she says, I don't want to go up in any more pressure. What else can you do to maybe manipulate the gas? Well, maybe we can change the high frequency pulsing. The faster we may make it help assist in oxidation. The slower we make the pulses bigger to pull CO2 out. So we do one or the other. I call them, it's a little bit of a low-cost maneuver because it doesn't have as much impact as something as like amplitude because it's more flow to the patient. But we would manipulate it down or up. If you were saying I want to oxidate the patient better, we would go up in anywhere from hertz, which is 60 breaths, or to 100 breaths, depending on the policy you guys choose.
It's called a pulse, you said?
Yeah, it's just high frequency pulse. Like it's how many pulses per minute.
Okay.
Oh, I went way too high.
Look at his one.
Kick off the bed.
So I'm at 600. So then we kind of manipulate those, and then if we needed more mean airway pressure, which would affect oxygenation independently, we would go on the peak knob. So it's just 3
That's when you started at 500 was the pulse.
pulses, yeah. On the guideline I'll show you, they have some like more particular disease states that have starting points that are a little different. 500 is like a very general guideline.
And if, let's say the baby, when we pick them up at Walnut Creek, they're on the oscillator mean of 12. So are you aiming for roughly 12?
You're roughly for 12. Because one thing I will say that it's on average. We have a little lower mean on average, but I'd rather you guys target and wean back than undershoot. So go say they're at 12. You can always get on 12. Check your gases. One of the things with this vent, it is very effective at removing CO2. So one of the things we do watch out for is, that's why we have this thing here, is overshooting, taking off too much CO2. Because if I call you and say, hey, we went from 100 to 70, I think we should go. You'd be like, well, is that going to hold that trend? Because if you're going to hold 30 for 10 minutes, you could possibly blow off too much. And that happens fairly commonly.
Is that an end title?
That's a TCOM.
Okay. And how much do you move the high frequency by, the pulse by?
People will either do it in a hertz, like the oscillator, by 60 breaths. That's how the conversion works, or just straight to go up to 100. It's really, the guideline says 60. A lot of hospitals make it easier, just go up to 100. So if you're at 500, go to 600. But the hertz is the common one, which is 60 breaths. You'll see a little number in the top right corner. That's like a peak amplitude number. I don't really teach off that. I just teach off mean for the most part. All right, let's see if we can conserve some gas. Oh my goodness. So it's not the biggest because I only have my laptop. I should probably printed these out. So what I have here, I pulled this straight from the manual. So it's like not made by somebody, it's straight from the manual. This is just the patient monitoring guidelines. It kind of goes over some details on what each thing does. But the important page is this one. So workflow, right? Increase oxygenation, well, easy. FiO2 is the early control. PEEP, frequency. And then that's pulse style flow rate is the amplitude. That's what that will translate to. So that's where we talk about maybe overventilating. You see that's one of the boxes we think about if we're going to end up blowing too much CO2 off. And then when we get more specific, this is probably another thing that's helpful. This is what I recommended to Stephen to kind of print and have next to you guys when they take it on transport, is having specific disease states to kind of give you some starting settings for.
He was just going